This is just a continuation from one of my YouTube shorts on how to convert different types of decimal numbers to fractions. First one, we have 0.12 and that's it. So remember, the first number after the decimal point is in the tens place with a th. And then the second number after the decimal point is in the hundreds place. So what we really have is 12 hundredths. That means 12 over 100. Here's the quick way to do it. When you have two numbers after the decimal point, just always divide this by 1 with 2 zeros. And when you have a fraction, you always ask, can we reduce it? Yes, we can divide the top and bottom by 4. We get 3 on the top, 25 on the bottom. So the answer for the first one is 3 over 25. Number 2, we have 0.12 with the bar on the top of the 1 and 2. This means we have a repeating decimal. This means we have 0. Both the 1, 2, 1, 2 will go on forever. The quick way to convert a repeating decimal to a fraction is to see how many digits after the decimal point are repeating. We have 2 of them, so just put them down and then divide it by 2 nines. If we have 0.123 with the bar on the top of the 123, then just have 123 over 3 nines, namely 999. I will explain why, but let me reduce this first. I will divide the top and bottom by 3. And we will end up with 4 over 33. And that will be the answer for this one. Quite different, right? Because this time we divided by 99, unlike what we did earlier for the first one, where we divided by 100. Now let's talk about why. So first, I'm going to let x equal the number 0.121212, so on, so on, so on. And because we have 2 digits that are repeating, I will multiply both sides by 100. So that the left hand side is 100x, and for the right hand side, we just have to move the decimal point twice to the right. So it's 12, and then with the decimal point here, and then 1, 2, 1, 2, and so on. Now have a look. This is 12 plus the decimal part, which is 0.1212, and so on. But how many 1s, 2s do we have? Technically infinitely many. Just like what we have originally for the x. So this, it's the same as x. So the equation is 100x equals 12 plus x. Then subtract x from both sides. 100x minus 1x is 99x. And then of course divide both sides by 99. This is why we divide both sides by 99. And imagine if earlier we have 3 digits that are repeating, you multiply by 1000, and then you will have to divide it by 999. And then for this right here, of course, we divide the top and bottom by 3, and we get x equals 4 over 33. Just like that. Okay, for number 3, slightly trickier, but not so bad. 0.12 with the bar on top of the 2 only. So this means we have 0.1 and only the 2 is repeating. So it's like this. 0.12222222. We can look at this number as follows. 0.1, and we add the rest, which is 0.0, and then here we have all the 2's that are repeating. For this one, it's not so bad because it's just 0.1. 1 is in the 10th place, so we just have 1 over 10. Done. But for this, we only have a 2 that's repeating starting right here though, so we have a spot. So what you have to do is the following. It's still 1 digit, right? So divided by 9, that's it. But because we have this additional 0, just imagine we divide it by 10, so you put a 0 here. So here's a quick idea. 0.2 with a bar, this means 2 over 9. But if you have 0.02 with a bar right here, this is 2 over 90. Why? Because you look at this equation and multiply by 1 over 10 or divide it by 10 on both sides. So you can put a 0 right here, divide it by 10, and then you just take this, divide it by 10, just like that. Now, whenever you have two fractions, you always ask, can we add them? Yes. Get the common denominator for the first one. We need to get 90, so multiply the bottom and the top by 9. So we get 9 over 90 plus 2 over 90. Together at the top, that's 11, and the bottom stays the same. Here, for the third one, we have 11 over 90. That's it.